Okay, so now you have a simulation. You made sure it worked. It does work, uh, and so now we need to make sure that we can actually capture some data, that we can use to assess what the result of our model might be. Um, so for for this, we need to think about instrumentation and where we're going to put instrumentation and why and what we want to measure. And as you get more into the class, into the projects, that's going to be much more of a focus. But for now, um, uh, I would just put some things that you think are going to be important, just test it out, play around with them, see what's available if you've never used FDS before, if you've never used PYSIM before. Um, like I said, I keep saying there's a lot of options that you can choose from, and and they're all it's pretty easy to put these things in there. So it's sometimes like, why not? So if you've never used FTS before, this might be a little bit of an introduction. You should do some research on your own. The FTS user guide, which is available from NIST, has a really good overview of what you can do in FTS, what you can't do, what data you can collect, how you can collect it, which different things that you can capture. It's very detailed, and I would recommend looking at that if you have any trouble. So one of the simplest things that you can do is that what you're probably going to do is you're probably going to want to draw a device, and to do that you use this little thing that I guess I don't know what it's really supposed to be, but so one thing you might want to do is might want to measure the temperature of the fire. So you can just click on that and go over here, and you can put a device right in the center of the fire right here. And so if you didn't notice, I try to keep things organized, and I organized it into a floor. And then in that floor I have the walls that I identified, the exterior walls, the floor ceiling. Then these are the new holes. I'll probably just add these to the floor ceiling group, like that, and then make a new fire one. Just to make sure, just to keep things a little bit organized, and I think it makes it look a little bit nicer, and it's easier to follow, especially when you have a much bigger model. If you separate it into floors, it makes it a lot easier. However, so we're talking about devices now, not to get sidetracked. So when you put a device on there, it's going to show up here, and on the sidebar it's going to show up here. So when you open that properties bar, it's just going to name them device. It's going to, if you put another device, it'll name it like device 1, like that. And I'm going to remove that for now. But so when you open this, it's just going to have a very generic name. The default value is temperature, but as you can see here, you can measure a lot of different things in the model. So when you're playing around with it, just take a look at the different things that you can do. What things do you think are important? What things are going to tell you whether the occupants are affected by different things or not? So like fractional effective dose or fractional irritant concentration, these things are things you might want to measure to see if they have an impact on where an occupant might be in a certain area. Other things do not have as much an effect, and they might have a more scientific background, or if you're doing a forensic analysis, they might be really important for that, but not so much with doing fire and life safety work. But for now, I think we're going to stick with temperature. And the location is kind of set by where we put it. The orientation is not exceedingly important for what we're doing right now, but basically it's just a coordinate system, and so -1 is going to be pointed straight down. If you just do 1, that'll be straight up. If you make this a 0 and put x as 1, it'll point to the right. If you make it a -1x, it'll point to the left. Similarly, for y, if all the other ones are 0, you make it 1, it'll point up, and similarly it'll point down. If you make it a combination, it'll figure out which direction, which vector direction that's going to point in. You can do that way. I'm just going to keep it -1 for now. But what you should do is you should come up with a naming convention that that makes sense to you, and hopefully it'll make sense to other people, that you can tell them what your convention is and they'll kind of understand. So I usually do mine based on location, and I'll just call this location 01, and then by what I'm measuring, so temp, and then when I'm doing this, I know where the location is, I know what the type of thing I'm measuring, and then I like to do an elevation. So for our first elevation, since we're starting at -3, I might do -2.8, something like that. And so I think this gives you a good amount of information with not a lot of characters and a lot of wasted space, basically. So I'm going to save that, and then so the cool thing about this program is I can just copy it, Control C, and then Control V, V, V. I guess I should do something better with the negative numbers, so like it'll be like that. And so for this one, I'll just I'll use that same convention, just copy that, and make this -2.6 as we get closer to 0, but I need to correspondingly change this z value to -2.6. I guess I didn't pay attention about whether this was -2.8, but that's kind of the elevation that we're looking for here. This will be 2.4. Again, this is just an example, so you should really think about what you want to measure and why, and where you can put devices that might assist you with measuring different things. I'm actually going to change this up and make it increments of 0.5 because it'll be a lot easier. Changing this up. This will be 1.5. And then 0.05. Right? Oh no. Like 0.5. -0.5. And so if we get any closer to the ceiling with this temperature device tree, when you put a device actually into the ceiling, you need to be just think about which direction it's measuring. Because when you put it into a solid object, it's going to reflect the temperature of that solid object, and obviously solid objects do not change temperature as readily as the air does. And especially in a model like this, since all our walls are inert, they will really not change temperature. If you want them to really reflect a real wall, you can find the parameters for gypsum or something, or some other type of wall, and put those into the model, and it will do a heat transfer calculation to measure what the wall temperature should be. But for now, we're just going to use inert, and yeah. So that's the example of doing a temperature device tree. And so I try to keep organized, so I'll make this one temp or location 01 temp, and so you can put all of these. You can put all these in this kind of folder type thing, and then you can actually copy this folder. And so if I wanted to measure, if I wanted all these to measure like I don't know, velocity, then I could have this one be, I could rename all of these like Velo, and make them, you know, kind of the same naming convention, just making sure I identify what the characteristic measurement is of. And if you have them in the same space, they're not going to interact. The FDS has the ability to measure as many things in like one spot as you want. So that's definitely not a concern. You can measure temperature and velocity at the same location. But that's temperature. That's one example of what you can measure. I just put mine above the fire, but maybe you want to put one in front of the door to see what the temperature in the doorways are going to be, or put one in front of where the stairs would be to see what the temperature would be there, or in front of the openings. Just think about what occupants might be affected by, and therefore what you want to measure to see if that's going to be a factor for them. Let me just check one thing. Is I think you can do visibility too. Yeah, so you can do visibility. That might be one thing you want to check too. There's also, I think there might be optical density. Is another one that has to do with visibility. But yeah, there's a bunch of things you should you can measure. You should think about where you want to put devices to best capture how the fire might impact the occupants. Like I said, this one's just above the fire, but so I mean, let's say you wanted to move all of these to a different location. You can actually just go over here, select them all, and move them over here if you want to. So yeah, it's a pretty cool thing that this allows you to do. And so once you kind of set things up, you can manipulate it, and I think it does save you some time, maybe versus some of the things that programming it may not. But there are some